Hi dear students, this is Vetri. Today we are going to see about introduction to trees. In linear data structures we have seen three different types, right? List, stack and queue. And we all know that what is linear data structure. So linear data structure, which is nothing but the data are arranged in sequence manner, right? So under data structures we have two different types. One is linear data structure and another one is non-linear data structure. Under linear data structure we have three different types, and under non-linear data structure we have two different types we are going to study. Okay, so first one is tree and another one is graph. So what is non-linear data structure? How the data are stored in non-linear data structure? Why we are going for a non-linear data structure instead of using linear data structure? See, for traversing a data node in linear data structure, it will be very easy. If we have only one address of element from the list or stack or queue, we can traverse all the nodes in that all the data in that data structure or in that list or stack or queue. Okay, but when it comes to non-linear data structure, so it will not follows the same rule. Okay, so if I have one address of node, means I cannot travel all the nodes which are present in that tree. Okay, not only in tree and graph also. So we have to follow some rules and algorithm or strategies to traverse all the nodes. Okay, and first what is non-linear data structure? Non-linear data structure, which is nothing but it's a collection of data or element which was arranged by using hierarchical method. Okay, it follows hierarchical entry. It will be for example, in colleges we will be under the principal there will be HODs, and under HODs there will be faculty members, teaching faculty members. After that there will be non-teaching faculty members. So these are the hierarchy, right? In families we can take grandfather, father, and then sons, then childs. So that's a hierarchy, right? So that's the whole principle of non-linear data structure. This is how we are going to arrange the data by using non-linear data structure. Here we are going to deal tree and graph. Okay, so first I am going to explain tree. What is tree? Why we are using the term tree in data structure? See, tree, which is nothing but, we all know the structure of tree, right? So it will be look like this. There will be a root like this, and then there will be some branches, and then in the tree there will be some fruits, and then it will have lots of leaves within the branches, right? Okay, see, same way I'm going to turn around. So I'm going to make this one as upside down. See, we are having a root like this, right? So which is root, and then we are having multiple branches, and then we will be having like fruits, right? So fruits, and then at last we will be having the leaf. Okay, so by using this I am going to compare how we are going to make tree in data structure. Okay, when it comes to handling data by using tree data structure, C, A, B, C. Slightly boring by using these letters, right? Let me explain with some other interesting example. See, vehicles. Under vehicle I am going to make two-wheelers, four-wheelers by vehicles. So under two-wheeler we will have bicycle and bikes. Under four-wheeler, so we will be having cars and luxury things. Okay, luxury vehicles. And then under cars we will be having multiple categories, multiple type of cars. Okay, like the different companies like Shift, Tata, Indica, and then so many things, right? So under luxury cars we will be having multiple options, multiple categories. We can list it out, right? So here this is how the hierarchies are arranged. Okay, so I can keep all the thing under vehicle, which is nothing but root. Okay, so here we have root of the tree, and then under that we have two, what is it? So we used to call this one as in tree we used to call all the element or all the data as nodes. Okay, so we can call this one as root node, and these all are nodes. So in trees we have taken as fruits, right? And then these are the connections, which are nothing but, so here we used to call that one as leaves, branches, but here we are going to call this one as edges, or else we can call this one as branches also, no problem. And what about the last entries? What about the last? So these all are leaves, leaves of the tree. So when we will call the node as leaf node, means if the node doesn't have any child, that means like this, the last node, the last row of the tree is always called as leaf node. Okay, so we will see the terminologies one by one. So here we go. So here we have the basic terminologies in trees. Okay, see, let us consider this tree. We are going to see one by one. Okay, what is a root node? Root node of this tree, already explained what is the which one is the root node. So the first node, it is always a root node. Okay, and then what is subtree? So subtrees are, which is nothing but from the root node, here we have two branches, right? Here we have two edges. So these edges are called as, we have two subtrees for root node A. Okay, so this one and the another one, and for C we will be having three subtrees. For B there will be two, right? So that's the concept, subtrees. And then what about path? So path, which is nothing but, for example, take K. Okay, so path for K is C, from the root node A to C, and then C to G, and then K. Okay, G to K. So the route from the root node to the destination node, right? So which is, the route is called path, right, for reaching the destination. So here I am taking the destination node as K, right? And then what about leaf node? Leaf nodes are, which is nothing but whether the node have no child, means, see, whether the node have no child. For example, E doesn't have any child, F doesn't have any child, like J, K, H, I. So these all are leaf nodes, right? And so we can call this one as child node also, right? Then what about successor and predecessors? So successor, which is nothing but the next node. For example, what is the successor of B? We can call E as a successor. Okay, and what about predecessor? So predecessor of B is like ancestors, the previous node which we have before that node. Okay, so for B, A will be predecessor. For E, B and A will be predecessor. Okay, so that's the terminologies. Then next one is level. So levels are nothing but, see, for this considering this tree, look, the level always for root node it will be 0, and then level 1, and then 2 and 3. Okay, so that depends on the levels, that number of subtrees we are having. Okay, so that's the level we are measuring from the tree. Okay, and what about the degree? So degrees are, which is nothing but then how many number of node which has. Okay, for example, take B. So what is the degree of B means? So how many nodes it have, how many childs it have? 2, right? So that means degree of B will be 2. For B it will be 2. For degree we have two categories. Okay, in degree and out degree. So which are nothing but 2 is out degree, because there is 2 outgoing node from the node B. Okay. For what about in degree? In degree, which is nothing but how many nodes the edge is coming from, to B. Okay. So here it's coming from A. The degree is 1. Okay. So these are the basic terminologies present in tree data structure, and in coming videos we are going to see about what are the different categories we have and different types we have in trees, and then how we are going to deal the basic operation in those trees. Okay. So I hope you understood the logics very well, and the basic terminologies are very easy. If you repeat once again, you will come to know how we are dealing these things in trees. Okay. So these basic terminologies are very important for further proceeding all the operations and the next proceedings in trees. Okay. So if you have any doubts, you can comment in comment section, and or you can write you wingslecture@gmail.com, and thank you so much.